Good day, students. I want to take you on hot cathode as a continuation of electrical conduction through gas. Remember, in our previous class, we mentioned the cathode ray and we discussed the properties of cathode ray. And for today, we are going to look at hot cathode. Now, specific objective. At the end of the lesson, I should be able to define thermionic emission, state the thermionic devices, draw the diagram of thermionic diodes and the characteristics curves, then mention the similarities between thermionic emission and photoelectric emission. Okay, the hot cathode. We know in the cathode ray, in the discharge tube, we discussed earlier, we say that the cathode ray is a stream of electrons. It is a stream of electrons, and we say that it originates from the cathode and move to the anode end. The movement of the cathode ray from the cathode end to the anode end is as a result of the ray being a negative charge particle. So therefore it is attracted by the positive charged anode. So we now say hot cathode is another way of producing free electron. Now you remember I told you that the charge carriers in gas is free electrons. Why do we call it free electrons? We call it because free electrons are the electrons that are already detached from the metal. They are detached from the metal, but they cannot be carried by non-conductors. So we call them free electrons. So that's the charge carrier for gases. So we say hot cathode is another way of producing free electrons. So apart from what happened in the discharge tube. So you know in discharge tube, electrons are produced from cold cathode. What we just did there was applying a very high voltage and a very low pressure to produce the stream of electrons. That one is called cold cathode. So here we are looking at a hot cathode. So we now say that whenever a metal is heated to a sufficient high temperature, electrons are emitted from the surface of that metal. And that is what we call thermionic emission. So we now define thermionic emission as the process whereby electrons are emitted from metallic surface when heat is applied to it. Now when you look at the diagram shows a hot cathode for producing electrons. You see that we have in a evacuated tube, it contains no air, it is only vacuum. So we connect it to a very high temperature, to a very high voltage, and we have a heater. You know, heater is such electrical devices such that whenever it is connected to electricity, it will become very hot. Now this heater, we make this heater with different types of material, something like tungsten. Tungsten is a very heavy metal. I told you the other day that tungsten is one of the heavy metals that are used in making filaments, because once the electric current passes through it, it gets red, it becomes very hot. Now in this diagram you see that the source of EMF is applied to the filament between the cathode and the anode, and the filament gets hot. Immediately it becomes hot, you see the electrons are released. You see the free electrons as they are released from the tungsten. Immediately they are released, they move at a very high speed. They move at a very high speed and they are attracted at the anode. So when they go to the anode, all of them are accumulated. They hit the anode. So you find out that in this case, these electrons that are emitted here, this property can be what? Studied. And it has various applications which we are going to discuss. Now, let us discuss the operation of the hot cathode. We said that when the cathode or the hot filament is heated to a very high temperature by a voltage source across its terminal, the filament emits electron by thermionic emission. Remember, we say thermionic emission is the emission of electron from the surface of metal when heat is applied to it. Okay? Now, extra energy is given to the free electrons at the metal surface. What is responsible for the extra energy is due to the what? The high temperature. They will do what? The free electrons will gain a greater kinetic energy as a result of what? The heat they receive from the filament. Now, the extra energy enables the electron to break away from the metal surface and they exist as free electrons. They break away from the metal surface due to the what? The extra energy they gain from the metallic surface. And this electron accelerates to the positively biased anode. The anode is already biased positively because of the what? The terminals of the what? The source of the EMF. So now we said that they produce current which flow through the what? The galvanometer. The galvanometer is used to detect, to show that what? The current is produced as the electron. You remember we said that electric current is the flow of electron in an electric circuit. Electron is something we cannot see. The essence of the galvanometer is to tell us that the electron has been emitted, which is responsible for the what? For the current that flows across the galvanometer. Okay. Now, we talk about the application of thermionic emission. The application of thermionic emission. We said thermionic emissions are applied in thermionic devices. So the thermionic devices are those devices that operate on the principle of thermionic emission. Now, examples of such devices are thermionic diode, X-ray tube, cathode ray tube. You know, cathode ray tube is on the principle of the cathode ray tube that the cathode ray oscilloscope is constructed and designed. The cathode ray tube has a wide area of application. It is also on the same principle that the cathode ray TV work. Know the cathode ray TV? That is the old model TV that makes use of tube. So that television works on the same principle as the cathode ray oscilloscope. They are the thermionic devices. So I mentioned the diode valve, or we call it thermionic diode, the X-ray tube, the cathode ray tube, and the cathode ray oscilloscope. These are the thermionic devices. Now, we are going to discuss those devices. Now, we start with the diode valve. What is a diode? You know, we said diode valve is a simple application of thermionic emission. Now, before we begin to discuss the features and the structures, I will firstly tell you that a diode valve is a thermionic device that is mainly used in rectification of alternating currents. Rectification of alternating currents. That means in conversion of alternating currents to direct currents, we use diode. Nowadays, due to the discovery of semiconductor devices, diode valves are not mainly used. So we make use of semiconductor diode. But they work with the same principle. The only difference between the diode valve and semiconductor diode is that the diode valve is operated by a very high voltage. So when the voltage source is not very high, it will not work. But semiconductor diode work even at a very small voltage, and that is why the thermionic devices, they require a very high voltage. So once the voltage is low, they will not work. That's one of the reasons why the CRTV, if you have it, you know that you will always use it with voltage regulator, because once the voltage is low, it will not work, because it is mainly thermionic devices. The tube is a thermionic device. The diode valve in it is also a thermionic device. But when you look at the modern television, the LCD, LED, and plasmas, you see all of them as semiconductor devices. They make use of semiconductor diode. And for that reason, even a very low current, a very low voltage can operate the appliance. So that is the major difference between the diode valve and the semiconductor diode. Now we say the diode valve consists of anode filaments. You know, I told you that this filament is made of what? Tungsten. Tungsten wire. Tungsten is one of the heavy elements that are used in making filaments. Both the filament bulb, the filament of cathode ray oscilloscope, the filament of CRT tube for television, the filament of diode valve, they are all made of tungsten wire. Even the filament of X-ray tube is also made of tungsten wire. Now, and a cathode which surround the filament. So when you watch the diagram, you see the anode and the cathode. So the cathode is just placed close to the heater. The heater, which is what? The filament. So once the filament is connected to the source of high voltage, it will now hit the cathode. Now hitting the cathode, then electron will be what? Released. That electron will now be accelerated. It will accelerate to the what? Anode. So when you look, you see directly heated diode valve and indirectly heated. The difference between the two, please watch the diagram. The difference between the two is that for a directly heated diode valve, the cathode is purely the tungsten filament. There is no other material that is used as cathode. But for the indirectly heated diode valve, you see that we have the filaments and we now have a material of the cathode. So the filament is sometimes they don't use filaments, they will just use ordinary heater. They will just use ordinary heater to heat the cathode such that the electron will be released. But when we indirectly heated, so there is no heater, the filament serves as the heater. So electron is always released at a very high temperature. Okay, the operation of diode valve. You say when the filament is heated to a very high temperature by a voltage source across its terminal, the filament emits electron by thermionic emission. Now the electrons accelerate to the positively biased anode and therefore produce current which will flow at the anode. The currents can be detected by the galvanometer. If you watch the operation of thermionic diode, you see that it is similar to that of what? The hot cathode. That is why we say they work with the same principle. The same principle of thermionic emission is very simple to understand. You just know that when the filament is heated to a very high temperature, what, as a result of the what? The voltage that is supplied across the terminals of the filament, then electrons will be what? Released by thermionic emission. So that electron, we say, is already what? Positively biased as a result of what? The terminals. You understand? The polarity of the terminals. That is responsible for the positive bias of that anode. So, you know, as electron flows to the anode, you know that the electric current will be generated. So that electric current that is generated is what is detected by the what? The galvanometer that is connected across the anode and the cathode. So that is how the diode valve works. Now we look at the diode valve characteristic. So look at the circuit. The two circuits, they are the same. It's just that I gave two diagrams so that you should understand that they are the same. The only difference is that in the first one, we have what? The current is purely what? Alternating current, which will produce what? A very high voltage. But in the second one, we have what? Direct current, but we have a variable resistor. The variable resistor there is to do what? To vary the potential difference and the current that is what? Going to the filament. So when a very high voltage is required, the rheostat, which is the variable resistor, will be varied such that a very high potential difference will go to the filament. Now, when you look, you see that the diode we have here is what? Indirect. In the second one, we have what? Both this first and second, they have indirectly heated diode because we have a material of the cathode. So you see, now in this case, that when the current that will be detected, it will pass through the milliammeter. which is the galvanometer. Now, there is also what? The potential difference applied across the terminal. Now, the characteristics circuit shows how the variation of the potential difference across the terminals of the diode valve will vary with the current that will be generated across the terminal. So that is this circuit, and we call it, this is the characteristic circuit. Now it represents the forward bias nature of the diode valve. Now let's look at the curve. Okay, before the curve, we discussed the operation briefly. Now, when the filament is heated to a very high temperature by voltage source across its terminal, the filament emits electron by thermionic emission. The electron accelerates to the positively biased anode and therefore produce anode currents, which flows to the anode. We said that the current can be detected by a galvanometer. Now, a voltmeter is connected across the anode and the cathode to know the anode voltage that produces the anode current. So, we now say the difference anode voltage are applied to obtain different anode currents. It is the variable resistor that we use to vary. Immediately we vary the voltage, we see that a different current will be produced at the anode. So now the variation is what we are looking at. So we now say that each of the anode voltage is denoted by VA, while the anode current is IA. So we said that each of the anode voltage VA are plotted against the corresponding anode current to obtain the diode characteristic curve. We are going to discuss next. Now, when you look at the curve, when look at the anode current versus anode voltage. So you see that initially increase in the anode voltage increases the anode currents, but the situation will not continue indefinitely. It will continue until a particular point will be reached where any further increase in the anode voltage will result in no increase in anode current. At that point, we call that point the saturation point, and the current corresponding to that point is called the saturation current. That maximum voltage applied is called the saturation voltage. So if you look at the curve, now you see that in the cold cathode, the anode, the saturation current is less than in the hot cathode. So that is to tell you, that's why the hot cathode is used mainly for what? Electron production. Because in the cold cathode, immediately within a short time, the saturation point will be reached. And as a result, the electron that is released will not be, it may not form a beam. You know, it is a beam of electron that is used to study the characteristics. So now in the next curve, look at it, we consider three situations where we have a cold heater, a warm heater, and a hot heater. We see that the curve is also showing that the hotter the heater, the higher the saturation current. And the saturation current is always what is preferred in rectification. Because if the saturation current is very low, it means that very high current at a very high voltage, then the anode can no longer carry the current. The current that will be generated can no longer be suitable for what? For rectification at the what? Anode. Okay. Now, this, if you look at this curve, you see that the curve does not represent the normal ohmic condition we know. It does not obey Ohm's law. Ohm's law states that the current is proportional to the potential difference or the voltage. So when you look at the current is no longer proportional because increase in the voltage at a point can no longer cause an increase in the current. And that is why we say that diode valve is one of the non-ohmic conductors, because the characteristics curve does not obey Ohm's law. So study this curve and know the difference between the cold cathode and hot cathode. So also know that the anode current is higher than that. The anode current is higher in the hot cathode than the cold cathode. Also, the saturation current is also higher. Okay. Now, we said that the diode characteristics curve shows the behavior of diode valve. The curve shows that diode current, that is IA, is not directly proportional to the diode voltage, VA. Initially, as the anode voltage increased, the current also increases until it reaches its maximum value. I told you that maximum value is what we called the saturation voltage. Now, the diode current IA increases until it reaches its maximum value. The maximum value of that current, the diode current, is called the saturation current. But with further increase in the anode voltage, the anode current remains constant. It remains constant. Or some cases, it will decrease. This maximum value of the current, we call it saturation current. And that point, we call it saturation point. So for this reason, diode valve does not obey Ohm's law and is called non-ohmic conductor or substance. So we say diode valve current, in diode valve, currents flow only in one direction. And that is why it is used in rectification in AC circuit. Please, it is in AC circuit we use it, not in DC. You know, it's one of the questions JAMB will ask you. They will ask you that diode is used as a rectification in alternating current circuit, direct current circuit. You know it is in what? Alternating current circuit. Okay. Now, we look at the similarities between thermionic emission and photoelectric emission. You know, photoelectric emission is another type of emission we are going to discuss in due course. It's one of our topics later in the term. Now, number one, we said that both the thermionic emission and photoelectric emission are surface phenomena. That means they always take place at the surface. Thermionic emission takes place at the surface of metal. Photoelectric emission takes place at the surface of metal. So they are both surface phenomena. Number two, electrons are released in both cases. So electrons are released in thermionic emission, likewise in photoelectric emission. Then number three, Energy is released in both cases. Yes, both of them are accompanied by release of energy. And number 4, energy transformation takes place in both cases. You know, in photoelectric emission, we see the energy transformation that takes place in photoelectric emission is from solar energy to kinetic energy to electrical energy. That is energy transformation that is taking place there. But in thermionic emission, the energy transformation that is taking place there is electrical energy will be converted to heat energy. Heat energy will be converted to kinetic energy. Then the kinetic energy will be converted again to electrical energy. So you see that in both cases we have energy transformation, even though it's not the same type of transformation, but we have energy transformation taking place in both emissions. Then number 3, increase in temperature is involved in both cases. You know, here in thermionic emission, we see increase in temperature will do what? Cause more electron to be what? Released. But in photoelectric emission, increase in temperature will only do what? Increase the kinetic energy of the electron that is released, what we call photoelectrons. So, increase in temperature is involved in both cases, even though increase in temperature does not have the same effect in both processes. So, in thermionic emission, increase in temperature increases the number of electrons that will be emitted. But in photoelectric emission, increase in the temperature will only cause the increase in the kinetic energy of the emitted photoelectrons. Okay, now let's look at the differences, the difference between them. Now, thermionic emission. In thermionic emission, electrons are released in the presence of heat in a vacuum. And in photoelectric emission, electrons are released in the presence of sunlight. Then in number 2, in thermionic emission, electrons are released at a particular temperature depending on the nature of the cathode. While in photoelectric emission, electrons are released at threshold frequency depending on the nature of the metallic surface. So these are the differences between the thermionic emission and photoelectric emission. Okay, next, we also look at the similarity between thermionic emission and liquid vaporization. Now, the similarities. Number 1, heat is involved in both processes. So, thermionic emission requires heat. Likewise, liquid vaporization requires heat. Number 2, both processes occur at the surface of the material. You know, thermionic emission we say is the what? Emission of electron from the surface of metal when heat is applied. You know, liquid vaporization is the emission of the water vapor from the surface of water when heat is applied to it. So in both cases, surface, both of them are also called surface phenomenon. Okay, number 3, in both cases, rate of the phenomenon increase with temperature. You remember I told you earlier that the rate at which electron is released in thermionic emission increase with increase in temperature. Likewise in liquid vaporization. So the higher the temperature, the higher the rate of vaporization. Okay, number 4, particles are released in both cases. We know electron is a particle, the water vapor is a particle. So both of them are particles and they are both released from the surface. Okay, number 5, both processes can reach saturation points. You see, as we discussed about the saturation points in the diode valve, so you see that once the thermionic emission proceeds at a particular point, it reaches saturation point. Likewise, the liquid vaporization, it reaches a saturation point. Then we look at the differences. Thermionic emission. He said thermionic emission takes place from metal surface, while the liquid vaporization takes place from the surface of liquid. Thermionic emission, electrons are emitted in that process, while in liquid vaporization, water molecules are released. In thermionic emission, it may not necessarily occur at a fixed temperature, but liquid vaporization takes place at a definite temperature for a given substance. And that temperature is what we call the boiling point, or we call it the vaporization temperature. So, in summary, we say that thermionic emission is the emission of electron from the surface of hot metal or from the surface of metal when heat is applied to it. Then we now say that thermionic emission is applied in thermionic devices such as thermionic diode valve, the cathode ray tube, and X-ray tube. Then we also say that the thermionic diode is used for current rectification in AC circuit. We also discussed the characteristics of the thermionic diode. We said the characteristics shows that increase in the voltage increases the anode current until a point is reached, which we call the saturation point. Beyond that saturation point, further increase in the voltage will not increase the anode current. We now say it is called the rectification of diode valve. And we now say that the characteristic curve shows that the diode is a non-ohmic conductor since it does not obey Ohm's law. So, thank you for listening. Then the assignments, you have the assignment here. So, you do them and submit to my Google Classroom. So you submit it as soon as possible. Thank you for listening and stay safe.